Now, our next question is from May June 2021, and question number 14. It says Q is a mixture of group 2 oxide and group 2 sulfate. Q contains equal amounts of the two compounds. Q is shaken with water and the resulting mixture filtered. A solid residue is obtained. There is no reaction when the solid residue is shaken with HCl aqueous. Shaking the filtrate with sulfuric acid produces a white precipitate but could be Q. All right. So basically, we're supposed to find out the mixture of the oxide and the sulfate from the given options. And we have provided. So the oxide, which we have to find out from here, and along with the sulfate, for this purpose, we need to see some information. There is no reaction when the solid is shaken with the HCl. So they are saying the solid was obtained in the residue and that could not react with the HCl. According to the literature from the book, from the notes, we can see, these are my notes. You can see here that magnesium hydroxide can react with the acid. So this could not be the compound which is in the residue because it can react with the acid. You can change the acid, you can put HCl instead of the sulfuric acid. So here, what we can say that the mixture was shaken with the water. So we have oxide of barium and oxide of magnesium. So magnesium oxide plus water produces magnesium hydroxide, and barium oxide plus water produces barium hydroxide. Now we have to see the solubility trend of the hydroxides. For this purpose, I will again show my notes. So that's an indication that solubility increases down the group. So we can see magnesium hydroxide has least solubility, and that is also mentioned here. So magnesium hydroxide is least soluble. In fact, it is present in the form of the solid. So the solid is produced by the magnesium hydroxide solubility, or you can say the formation of the magnesium hydroxide is least soluble. However, with magnesium, because the insolubility of the magnesium hydroxide, it is mentioned here. Magnesium hydroxide is insoluble in water. Now we go back to the question and we see that this option can be phased out. It could not be magnesium hydroxide in the residue because uh, okay, so we can say that magnesium hydroxide is a solid because it does not soluble in water, whereas barium hydroxide is soluble. It is soluble because so it does not form the solid. So barium hydroxide must we need to see which of the compound could be in solid residue. So solid residue could contain magnesium hydroxide because it is insoluble, along with barium sulfate because it is also precipitate. If we look at the trend of the sulfate, so again we need to look at the nodes. Among the sulfates, magnesium sulfate is very soluble and barium sulfate are insoluble. So the solid could also contain barium sulfate and not the magnesium sulfate. So this is solid, and another solid could be barium sulfate. it could not be the magnesium sulfate because that is soluble. I need to write here. Barium sulfate is a solid. Magnesium sulfate is soluble. The one which is soluble does not form solid. So we have now concluded two solids present in this option. Now it means that all the options could be from here A, B, C, D, but not the magnesium sulfate because magnesium sulfate is soluble. So we can take out this option. And barium hydroxide was soluble. Magnesium sulfate was soluble. So option B becomes incorrect from the first statement. Now it also says there is no reaction when the solid residue is shaken with the HCl. So we does not form reaction with the HCl. We know that the formation of the sulfate compound is the one which does not form the reaction with the HCl. So that is the barium sulfate. Magnesium sulfate, on the other hand, is soluble. Magnesium sulfate is soluble, so it can give reaction with the HCl. It reacts with HCl. But barium sulfate is a solid and it protects the surface of the sulfate, so it uh, doesn't react with HCl because of the presence of the protective layer on the sulfate which lets it insoluble. So we can conclude from here that it could be barium sulfate which does not react with the HCl. So it could be barium sulfate. Now the last is shaking the filtrate with sulfuric acid produces a white precipitate. Shaking the filtrate means the one which was soluble, which was not present in the residue. Instead, it went through the filter paper. So that is called filtrate. So the one which passes through the filter paper and not becoming a solid could be barium hydroxide, which is more soluble than magnesium hydroxide. Barium oxide is more soluble than magnesium oxide because of the reason that magnesium hydroxide was forming solid, whereas barium hydroxide is more soluble. Barium hydroxide is more soluble than magnesium hydroxide. So the one which does not, which forms a white precipitate and it is also a filtrate means it could be barium oxide. It passed through the filter paper and when it reacted with the sulfuric acid, barium oxide reaction with the sulfuric acid produces barium sulfate. Now barium sulfate is a white precipitate. So this is the one which passed through the filter paper and it formed the white precipitate when it reacts with the sulfuric acid. And we have already discussed that it is a barium sulfate previously which was not reacting with the HCl. No reaction was possible with the HCl. That is barium sulfate. So both the options of option A are the correct. Barium oxide and barium sulfate both are present. So that's why the correct option becomes option A.